Okay, this is a video on how to solve stoichiometry practice problems here. One thing you must have when you start this is you must have a balanced equation, and here we have it at the very top. Um, let's just go ahead and get started. The first one reads, given 21.5 grams of iron, how many grams of hydrogen gas is produced? So we're trying to produce hydrogen gas, and we want to know how much it's going to be, how much is going to be there. So we need to identify a couple things. We need to identify what we have been given, and we're going to label that our A. And what we're trying to produce or what we're trying to find is going to be our B. Okay? And so the next thing we have to do is we have to do a little chart like so. And then we have to write down what we've been given, and that's going to be on our A side. And this is our B side. We always travel from A to B. Left to right across the page. So let's write down 21.5 grams of iron, right? And this is a mass-to-mass problem. It's the longest one out of the Stoich problems. It's most likely the hardest one. But let's go ahead and work this. So the first thing you have to do according to your flow chart is you're starting with the mass here, and you're going to end with the mass over here. And along the way, travel along this path to get to this point, and you have to perform certain functions along the way. 1 mole of the molar mass of A, the mole ratio, that's moles of B over moles of A, and then you have to perform the molar mass of B over 1 mole. See, everything on this flow chart is important. This is the A side, this is the B side. This is what we know, and this is what we're trying to find, okay, what we don't know. Okay, so let's go ahead and solve this problem. So the first thing we have to do is get 1 mole over the molar mass. Let's make this bigger so we can see that. 1 mole of iron over the molar mass of iron. We're going to call that 55.8 grams of iron per 1 mole of iron. And now comes our mole ratio. I'm going to write down mole ratio down here. Okay, and so that's going to be moles of B over moles of A. Now B is your hydrogen gas over here, and A is going to be your iron over here. So the moles, how we determine the number of moles, we look at the equation, and we find that our hydrogen gas has a 3 in front of it, so that's going to be 3 moles of hydrogen gas. And our iron, our A, has 2 moles. We look at the coefficient. That tells us the number of moles for that substance. And so I write 2 moles of iron here, and we're not done. Okay, so what we've done, if you look at our flow chart, is we have done this part here, and we have done this part here, but we have to do this last little bit right here, which is the molar mass of B, which is going to be our hydrogen gas over 1 mole. And so when I do this, let me get this page right and then do this. Okay, molar mass of B. So we have 1 mole of hydrogen gas here, and the molar mass of this hydrogen gas. For 1 hydrogen, that would be 1.01 grams per mole. But since we have 2 of them here, we're going to put 2.02 grams of hydrogen, okay? And so now what we have to do is we have to solve it with our math, and we have to understand that we're going to multiply everything across the top first, and then we're going to divide by everything across the bottom, okay? So we have 21.5 times 3 times 2.02. And if I remember right, that's going to give us 130.29, I think, I remember right. And then we have down here 55.8, and we have to multiply that by 2, and I believe that comes out to be 111.6. So when you divide that out, we get something like 1.47, or no, 1.16, I think. 1.16, I think. And that would be the grams of hydrogen gas formed. Okay, so you have to make sure that you multiply everything across the top first, and then multiply everything across the bottom, and then do your division, and then you'll solve it. Okay, so Let's do another one. This one is how many moles of iron 3 oxide are produced when, or if 63.7 grams of iron are used in the reaction. So how many moles is what we're trying to find? That's always going to be our B. So grams of iron is going to be our A. That's what we already know we have. And so what we're going to do is draw our chart again. And we're going to go ahead and write down what we do know. That's our A side. This is our B side over here. 63.7 grams of iron here. And we're trying to find moles of Fe2O3 over here, iron 3 oxide. All right. So what we've got to do now is we've got to do 1 over the molar mass. So that's going to be 1 mole of iron over the molar mass of iron, which is 55.8. We calculated that from our first problem. And then, according to our flow chart, if you have that flow chart handy, we have to perform the mole ratio. And that's always going to be moles of B over moles of A. The moles of B is our iron 3 oxide. And if we look at our equation, iron 3 oxide is right here. There's no number in front. You don't see it there. But there really is a 1. We just don't have to show it. So we're going to put 1 mole of Fe2O3. And for the mass of iron, or the iron here, the moles of iron, we're going to look at our equation. We find iron again, and there it is. There's a 2 in front, and that coefficient. We're going to put our 2 down here. 2 moles of iron, okay? And so now the problem becomes 63.7 times 1 times 1, which really is going to be 63.7, okay? And then you're going to take 55.8, multiply by 2, becomes 111.6, I believe. And if we do our math at all, we comes out to be something like 0.47 or 57, one of the two. And that would be moles of Fe2O3. I'm just kind of doing this off the top of my head. So that's how you solve a couple of stoichiometry problems using your stoichiometry flowchart. When you have a problem that looks like moles right here, when you're trying to find moles and they're giving you moles, that's a mole to mole problem. And the only thing that you're going to have to do is you're going to have to perform the mole ratio. And that means the number of moles of B divided by the moles of A. And that's a very simple problem to solve. It's a one-step problem. If you have any questions, just give me an email, give me a shout out. Have a good night.